for trouble.
And make it double.
Hi, my name is Kyla Safira Zahra.
And my name is Carolyn Manilin.
And we're from
Binasco Bogasi. So, you may or may not have heard of it already. A landfill that becomes the final resting place of all the trash the area around it produces. Every day, more than 7,700 tons of trash is brought here, and the gigantic piles grow more and more in size.
As students of Binasco Bogasi, we're no strangers to this landfill. The stench becomes nearly palpable on some days, and it becomes a slight nuisance to the students and staff of our school. But a slight nuisance to some can prove devastating to others. Bantar Gebang negatively impacts many aspects of the nearby citizens' lives and poses risks to both their health and well-being. Out of many things, Bantar Gebang contaminates the water, pollutes the air, and is a feeding ground for sickness.
Now, as students and leaders of tomorrow, we should start thinking of the future of Bantar Gebang. If the ever-growing pile of trash keeps on growing at its current rate, this will prove catastrophic in the near future, which is why we've come up with Tier-Compost, a compost system not only focused on tackling organic waste, but also inorganic waste, such as styrofoam and plastic.
The base structure is fairly simple to make. Instead of getting rid of old toy boxes or storage boxes, you can instead repurpose them into the system. The setup requires a minimum of 3 containers along with their lids, metal mesh similar to those found in chicken enclosures, mealworms, superworms, and earthworms.
First, take 2 of the containers and cut out the bottom, but while still making sure to leave a margin of at least 1 centimeter on each side, smaller if you're using smaller containers. Cut the metal mesh according to those holes, but make sure to cut a little bigger to make it more secure when sticking, and attach them so that the mesh covers the holes.
Then take the lids of 2 containers and cut out holes according to the size of the holes on the bottoms of the containers. Then poke out holes on the sides of the containers near the top for aeration. Lastly, stack the containers and lids accordingly, and the base structure is complete.
The top layer is dedicated for degrading inorganic materials, mainly plastics and styrofoam. While this process may take some time, the process can be sped up with an increase with the number of mealworms and superworms put in the layer. It has been proven that these worms can break down polystyrene. Studies have shown that larvae fed with only styrofoam for 1 month thrive just as well as those fed with bran. Polystyrene is digested by the worms and mineralized into carbon dioxide and incorporated into lipids.
This study was conducted on mealworms alone, but it has also been shown that superworms possess the same ability. They are more efficient and aggressive when it comes to consuming polystyrene. Another pro to using superworms is their longer lifespan and the fact that they remain in their larval stage for over a year when they are in constant close contact with other superworms.
The second layer is based on a more conventional composting method, the use of earthworms to break down organic waste like the common kitchen scraps each household produces. These worms eat food scraps, which then pass through the worms' bodies as nutritional compost. One thing to remember is that composting worms are different from earthworms, and while earthworms, which are more readily available, can be used to compost, we need to turn and mix the compost more often as they like to burrow deep.
Luckily, with our tier-compost system, it is simple to lift only a certain part of the system to access a certain tier. This also applies to the top layer, as it also needs to be mixed to ensure that the worm castings drop onto the next layer. To test out the effectiveness of this compost, we planted green beans in regular soil and soil mixed with our compost. We then compared the results of the two based on a few factors, first of which was the height of the plant. The average between 2 plants grown in regular soil was 7.25 centimeters tall, while the average height for 2 plants grown in compost was 8.5 centimeters tall. Second, the length and density of the roots of the plant grown in the compost was greater than that of the one grown in soil. And lastly, the average size of the leaves in the soil plant was 1.6 centimeters, while it was 2.3 centimeters for the compost-grown one.
There are some ways we can improve and make better use of the system, the first of which is scaling it up to an industrial level. As part of our approach is to reducing the load to Bantar Gebang, we suggested processing some of the waste so that less is sent to the landfill. If we scale this up to an industrial level, with automated mixing, we could in fact turn trash into something useful for our country, as it can be sent to farmlands to better our crops.
Now, the second way is the development of an extension to the system involving a UV light box with curved sides lined with a reflective surface like aluminum foil, in which we could put plastics in before feeding to the worms. It has been shown that exposure to UV light makes plastic brittle, hence easier for the worms to eat rather than soft plastic like that found in plastic bags. And a final improvement would be a change to the structure, with addition of an extra layer to prevent mealworms and superworms from getting into the earthworm layer. Although it is inevitable, but they will decompose. This is just to minimize the amount of that happening. And an addition of a layer that functions specifically as a food waste loading part, which will be placed in close proximity to the earthworm layer so that the earthworms can migrate up towards the food, and the final layer will only be consistent of the final product.
We hope that with Tier-Compost,
we can further the development of waste management in Indonesia.
That's all, and thank you!